Okay, welcome to the Manhattan GMAT Study Hall for November 17th. Today's topic is word problems that require organization. What we've seen, I guess it's not November 17th, it's December 1st. Let's fix that. Okay, welcome to December 1st Study Hall. What we've gotten as submissions so far in a lot of cases is these kinds of word problems where people are messing up on very long problems and they're thinking that the issue is the problem material itself, when in reality the issue is probably more organizational. So what we're going to look at today is basically how to approach problems with lots of words and confusing text, and how to make that into something that's going to be a little bit more workable. So how to deal with large volumes of confusing text in a math problem. Basically the deal. Before we get started, you guys know the drill. We have to do the usual warnings about content and so on. So let's do that. Please don't submit things that are too general. Please don't submit things that are too specific. Please no personal issues. Especially this. Remember that we have forums for this reason. So if you have a question that's just about one problem, please don't submit it here. Please submit it on the forum unless you have a more general question to ask. Also, please, obey the principles of basic business etiquette. A couple more examples of what you shouldn't do. This is a personal study plan. That's not the point of these sessions. So make sure you don't focus on that kind of thing instead of a study hall topic. Also, this person is not asking a question really here. I mean, there's no specific question here other than I'm not scoring as well as I thought, and that's everything. That's the whole test. So you got to be specific. This is a single problem. Again, please don't use single problems. Single problems should go on the forum. Finally, you got to realize we get a large volume of submissions, so we do these based on submissions, but also there will inevitably be a lot of submissions that we can't use because there's just too many. So we try to pick the ones that make the best and most coherent topics for the study hall. Finally, check the archives, please. There's almost 50 of these sessions by now. That's quite a few. A lot of you guys have been submitting things that are already in the archives, sometimes even a couple of sessions. So if you want to submit something that has already been covered, you've got to get a new angle on it. You've got to be like, I want to discuss this aspect of this kind of problem that we haven't discussed yet. So if we've already had a session on percents, but you don't think we've seen percent word problems, you can do that. But if we've done a session on percents and somebody says, I want to do percents, we will just not use that one because it's already in the archive. So, people are moving things around. Let's stop that from happening. Okay, that takes care of that. All right. Any questions about the rules? So you have a smiley face icon over on your left. Please click it if you are okay with these rules and regulations. Okay, smiley face icon. All right, good to go. So remember, the topic of the day is this: organization for word problems. So large volumes of confusing text. And what we'll do is start out with a single problem and then build a discussion and then attack some more problems with that discussion. So here is the basic tool that you're going to use to answer these questions, the answer buttons. You should see those starting right now. Does everybody see those answer buttons? Give me a smiley face icon if you see those. Okay, those are what you should use to answer the questions. Please do not answer questions in the text box. Please do not click more than one time. If you click twice on the same letter, then your second click will take the choice away. It will delete it. So answer buttons, please use them. Any questions before we get started, please go ahead and type in the text box. Otherwise, we will get cracking. Okay, these problems in today's session are all from the GMAT Prep software, if anybody is tracking sources. This one is in both. This one's in the GMAT Prep and the official guide. Give it a shot. Also, I'm going to give a little more time. Remember that 2 minutes per math problem is not for every math problem. 2 minutes per math problem is an average. So when you get a problem with a lot of words, one thing is that you can definitely take more than that amount of time. You still can't go crazy with it, but on a problem this long and convoluted, it's okay to take a third minute. So 3 minutes overall. Go for it. Have fun. Okay, ladies and gentlemen, boys and girls, that's 3 minutes plus the discussion time, so we need to get some answers up there soon. As in next 10 or 15 seconds, kind of soon. Remember to please use these answer buttons that you have. Answer buttons. Please use them. Also, if you don't have an answer, for some reason it's entirely the second half of the alphabet here. Raj, Serena, Sohail, Travis, Wanja. Remember, this is the GMAT. This is not a test where you can not answer things. So even if you have to guess, you had better get used to the notion of guessing. So, all right, let's take a look. What's the challenge of this problem? Like, let's just do an opinion poll here. Go ahead and tell me in the text box. I mean, here's your answers to this problem. Here's what you guys gave. You gave this. So everybody's all over the place on this one. The only answer that people didn't pick was D. So there's no clear majority. So obviously people thought this problem was hard. What was hard about it? Text box. Because this is one thing that people don't think enough about. Like, it's not always, in fact, it may not even usually be the substance of the problem that makes it difficult when a problem is difficult. Instead, a lot of the time, it's the functioning of the problem itself. So, yeah, like, lots of words, figuring out how to structure it. So for the most part, your answers in the text box are centering around one theme, which is that with problems like this, the primary difficulty is usually based in organization and understanding of the problem statement. It usually has nothing to do with the math. Like in these kinds of problems, once you have the problem statement set up, usually the math is really not that bad. But the challenge is like, what do we do with all these words? So let's talk about that. What do you do with all these words? Well, when you have a problem like this, and any word problem really, there are two stages of understanding, which are, number one, you have to understand the situation, and then you have to make the situation mathematical. And these are very different things. Like they're not the same. And what's interesting about tests and about school type stuff in general including tests like this, is that people don't really think enough about number one here. Which is interesting because in any sort of real world example, people will absolutely make sure that they really have number one in hand before they start doing number two. Like if you are going to start planning a diet for yourself with, grams of carbohydrates, protein, and fat, no one, and I mean no one, is going to just randomly start throwing numbers around without understanding what the situation is first, without knowing what are these things, what are carbs, what are fat, what are protein, what do they do, how do they interact with each other. So you want to take a cue from that sort of real life handling here, and you want to handle this in the same sort of way. You want to make sure that you do, as trivial as this might sound, you want to make sure that you do the first of these things before you do the second one. So understanding the situation means you're not doing math yet. No math yet. So in other words, if you start this problem by writing down an equation, then you are already in big trouble. Unless you magically understand exactly what is going on in it, which I bet you don't. So understanding the situation is really just the following basic questions. What quantities are in the problem? And, under what circumstances? Like what is interacting with what? That's really kind of it. But a lot of people don't even get this far. A lot of people are really not even to the point of understanding what the quantities are in this problem. Tell you what, just real quick, in the text box, how many quantities are in the problem? Shoot me a number. How many quantities are there? See, we're getting anywhere from 1 to 6. So what's going on here is that people are totally not even down with the basic fundamentals of what's going on here. You can't, needless to say, you can't start manipulating things unless you know what you are supposed to be manipulating. Again, it all sounds kind of like common sense when it's phrased that way. But you can't do math with things that you don't understand. You can't manipulate if you don't know what you're manipulating. So let's talk about what we should do when you see a problem like this. When you see this kind of problem, the first thing you have to do is read it twice. The first thing you want to do when you read it the first time is completely ignore the mathematical relationships. Instead, concentrate on understanding the situation. What quantities are in the problem? Just focus on what the quantities are and not on how they interact yet. Just what are they? Because again, think about diet planning. You can't start putting together carbs and proteins and fat until you know what a carb does and what a protein does and what fat does, and then you can figure out how to put them together. But otherwise, it's just like random combinations of randomness, and you won't be a very healthy person. So you have to understand what the components are first. So what are the quantities? And the key is that you can make a table of these quantities before you even start doing any mathematics. So read twice. Let's box a couple of these guys. The first time, you want to make sure that you ignore the math. What are the quantities? Make a table. Don't even worry about the math yet. We're not even close to there yet. So let's do that for this problem. What are the quantities in the problem? Well, we have this year, Henry will save a certain amount of the income. So he has a savings this year. And then he has a spending this year. He will spend the rest. So that's the second quantity. And then next year, and there's also, if you want, you can say there's a total income as well, although that's not a separate quantity because that is the sum of these. So total income for this year. Next year, he will have no income. That's not a quantity. But blah, 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 blah. Saves this year, we already have that. That's already a quantity. That's this color. But this is new. Available to spend, we have not seen. So that's another quantity. Available next year. There's no savings next year because he doesn't have income. So, and then there's a fraction that they're asking you for of this year's income. So there's some fraction of that. Let's put that over here as a quick note. Fraction of total income. And then so the spending this year will just be the rest of it. So that's the rest of it. So that next year, the amount that he has available to spend, okay, we've seen that already, will be equal to half the amount that he spends this year. We've also seen that already. So, hey, this is not that bad. There's really only 3 quantities, although there's a couple of relationships among those. Like you have a total income composed of the first 2, and there's this fraction thing going on. But there are really only 3 moving parts in this problem. So you can do that. So let's make a table. And again, you can make a table without having any mathematics in the table. Because, you don't do the mathematics until you have a table. So it doesn't need to be anything super duper amazingly fancy. It just has to be like, okay, we have this year, spend and save, spend, and then next year available. It's next year. And those are the quantities. So we don't know what any of these are, so now it's time to start doing algebra. But smiley face if you guys see the significance of this step. I mean, this is not genius, it's not anything earth-shattering, but a lot of people out there have the bad habit of doing stuff before they know what they are doing. And I mean, that's a lot like using a map if you don't have a destination yet. And it's just, you can do things with the map, but you're not going to do anything worth doing. So now let's get the math in there. So number 2 in this little thing here is just do the math. Go back and do the math. So read it again. Read the problem a second time. This year, Henry will save a certain amount of his income and will spend the rest, and it's a fraction that he should save. So let's call that, I mean, that's what we're solving for. So we need to have we want this fraction. So let's call it F, because if you don't have a variable for the thing that you want, then you're probably in some degree of trouble. Let's say your total income is I. Then text box, please. What is the amount that Henry saves this year? how does f is a fraction? So like think about f being 2/3 or something like that. None of this. There's no interest in this problem. Not yet. We're not using the 1 plus r yet because we're just talking about it's fi. So because your total income is I, and you have a fraction of that. That is f to f fraction. So that's going to be f fraction times your total income I. And so then smiley face if everybody understands that. It's a fraction of the total income, and they're telling you here that's the quantity that is saved this year. That's the brown quantity. So we can color code this over here too. So text box, please, what is the amount spent this year? And remember, you don't want to define any more variables than you absolutely must. So how much is, if I is the total income, and it's the rest. So there's two ways you can do it. You can either think of it as a fraction 1 minus f times the overall income. That's the remaining fraction. Or you can do what Tabiba is doing, and you can just take the whole income and you can subtract out fi from it. I mean, those are definitely the same. So you can do that also. I minus, that's supposed to be fi. Let's fix that. I minus fi. Okay. Now we need to use this relationship that for each dollar saved this year, there's 1 plus r dollars available. So this means you just take the amount saved this year and you do what to it? Text box. You multiply by the 1 plus r. So you take that over there and times 1 plus r will give you that. So 1 plus r fi. There we go. And then we just do the last thing they tell us to do, which is next year available, this purple thing, is half of the blue thing. So purple thing is 1/2 blue thing. Just so that we don't have to deal with fractions, we can double that. So 2 times purple thing equals blue thing. So 2 times 1 plus r fi equals the 1 I minus fi. So that's 2 plus 2 fi plus 2 r fi equals I minus fi. At this point, we can actually strike I. We can divide I from both sides because it just goes away. So if you get that, you wind up with 2f plus 2rf equals 1 minus f. Do a little bit of rearranging, and you get 2rf equals 1. You want the f's on one side, so you have 3f plus 2rf equals 1. And so then you do a little bit of factoring, pull out the thing you want to find. Let's move this up just a little bit. pull out the thing you want to find, which is f3 plus 2r equals 1, and there you have it. So there you go. Now, the point that I want to emphasize about this problem is that, number one, it's a very hard problem, and most people get it wrong. But the reason why most people get it wrong is that they don't organize it. Because one thing with which I think you will agree here is that no single one of these steps is really that hard. Like, every individual step of this problem is pretty routine. You know, you make the fraction of a total, you make the rest of the total, you double something, you multiply something by 1 plus r. I mean, there's no hard math here. But what makes this problem really hard is that most people are really not down with setting it up in the first place. They don't even get to a place where you can do this math because they don't know what the quantities are yet. So the main thing I want you to get out of that is the importance of ignoring the math the first time you read a large situation. And I mean, if that seems weird, it shouldn't seem weird because that's exactly how real life works. I mean, if you were going to set up a diet, I know not to keep overusing this example, if you were going to set up a diet plan, you would absolutely have to make sure you knew what all this stuff was first. I mean, if you don't know what proteins, carbs, and fats do, you simply can't do any math with them. And you should think of these the same way. So, there's a question in the text box, is it usually better to start with the final quantity? I mean, if you have to solve for something, it helps if it's a letter. You know, if the final quantity is the sum of 2 or more things, you might not have a single letter for it. But here it's a fraction, so that's definitely something you want to have in your pocket. I mean, unless there's a good reason not to, then it helps to have a variable that stands for the answer, because then you can solve for it once you've got the math. So, I mean, again, maybe not 100% of the time, but if you're in doubt, then that's certainly the best place I could think to put a variable by default. Any questions about the problem? If you have questions, go ahead and put them in the text box. There's the work. There you go. Okay, a couple people are typing. Let's see what they're typing. By the way, when you type messages, please deliver the message to everyone. Please don't just send it private, because if I'm going to answer it in a study hall, then people should know what I'm responding to. So I'll wait until a couple people type things. I can see people are typing. Okay, someone's typing good explanation. Well, thank you. I appreciate that. One other person, if we would have, I mean, would we have gotten the same answer? Yes, of course we would have, because the problem has a single answer. So, I mean, the work would be different. You definitely wouldn't want to have 3 variables for saving, spending, and income, because the income is the sum of those other 2. Like, one thing that's a definite rule here is you don't want any more variables than you need. So let me put that on the board real quick, because this is also key. There's this previous study hall where we went over this idea, but it never hurts to repeat. So, I mean, would we have gotten the same answer? Sure. But the main principle here is don't define any more variables than you need. So if you have a relationship between 2 or more quantities, you shouldn't need extra variables to start defining that. So for instance, if you let X equals the amount saved this year, and Y be the amount spent this year, then total income this year should not be a third letter. Like, it should not be something like I. It should just be X plus Y. So you don't want that third variable in there because you don't need it, and it's just going to make your life more difficult. So that's the thing that it is. Like, you can define these things any way you want. Like, in the case that you're asking about here, yeah, you'd get the same answer. You would have to, because you don't have a variable for the fraction, you would have to divide savings by income at the end of the problem. But if you did that, then you would wind up with the same sort of thing. Let's talk about this. We addressed this already, but it's definitely a strong enough point to be addressed again. Is this statement true or false? I'm going to highlight it. Tell me in the text box whether that is true or false. That purple statement. Is that true or is that false? It's very false. So let's talk about why. Yeah, like, it's okay, if you can see what JC is writing. I mean, remember that, guys, common sense here. 2 minutes per problem is an average time. So, I mean, I know this is a test, and people don't tend to apply common sense to tests. But time management is a very common sense kind of thing, and you really have to use it. I mean, 2 minutes is not every single problem. It's really not. 2 minutes per problem is an average. So some problems will take substantially longer than that. Some problems will still take substantially less time. So you need to judge how to adjust this instinct according to the volume of stuff in the problem. Like, for instance, okay, like this is a GMAT prep problem. This is also in the OG. The reason we can use it is because it's in GMAT prep. But let me refer you to 2 official guide problems that I can't put on the board. But they'll make a good reference. I'm assuming you guys all have the official guide. Official guide 12th edition number 163, that's this problem. Nobody is going to finish this problem in 2 minutes, the one we just did. Because, you know, are you kidding me? I mean, look at it. But then the problem right below that in the official guide, check it out later if you don't have your official guide on you right now. The problem that's 164, whether you know how to do 164 or not, you should be out of there in 30 to 40 seconds. Like, no one should possibly take more than like 30 to 40 seconds on this one. Because that's just, if you don't have your official guide, it's just one operation using a negative exponent. So you either know how to do those or you don't. And in either of those 2 cases, you're done really fast. If you know how to do it, it's a single operation. If you don't, then you don't know how to do it, and you should get out of there. Because it's not like you're going to figure it out if you don't know how. So it's an average. It really is like, you know, it's like anything else, it's an average. Like if I paint houses and it takes me 4 hours on average to paint a house, then I will not go into a giant mansion and say, I will paint this house in 4 hours, because I know I won't. But if I get a little apartment, it won't take me 4 whole hours. So you got to adjust your timing intelligently, just as you would for anything else. That's what you want to do. And I mean, I do hope that no one has been following an exact rule of 2 minutes per problem. I mean, if you do, you'll notice relatively quickly that you spend a lot of time just staring at the shorter problems. Any other questions? If you have them, text box. If not, let's rock and roll. Okay, here's another problem. Just in case you haven't had enough about problems with pay and take-home and savings and stuff, here's another one. Give me a timer. Let me resize this problem real quickly. Okay, that should be in the window now. Here's a timer for you. Go for it. Okay, boys and girls, let's pick something in the next 20 seconds maybe, because it's been about 3.5 minutes now. So let's pick something. That's Nitin and Z number 2, Prabhakar, PTM, and Serena. Okay, remember we're over 4 minutes now, so if you guys are still not answering the question, that's going to nip you on GMAT day. Prabhakar, Serena, we're looking at you. No answers. Okay, so here's what the rest of the class has. So again, we are sort of all over the place on this, but at least one of those 2 popular answers is the right one. But let's go. I mean, you're not going to be able to read this one time. You know, it's just not going to happen. So we're going to read it twice. So read it twice. First read, remember what you want to do is what is the situation, what are the quantities in the problem. So, well, take-home pay was the same last month, each month last year, and she saved the same fraction of that take-home pay every month. So we have a monthly take-home. We have a constant fraction saved. Notice, jumping a little bit ahead really quickly, that's that fraction. So we definitely want a variable for that. And then we have take-home pay each month. The total amount of money that she had saved at the end of the year, is that a new quantity? The total amount of money that she had saved at the end of the year. Text box, please. Is that a new quantity, yes or no? Yeah, it's not, because it's just what? It's just 12 times the constant fraction saved. So times 12 is total saved. So you have the 12 times fraction times monthly is total saved. So you don't need another variable there. And then there's the amount of the monthly that she did not save. So that's the rest of, you shouldn't need any new variables for that either, because that's the rest of it. So there's really not, again, there's not that many quantities going on here. You've got a monthly pay, you've got a fraction. So we only need 2 variables. I mean, we'll make a table in a second. But we are only going to need 2 variables to solve this problem. And if you have more than that, it's going to start making the problem unmanageable. So you really want to make sure that you don't waste variables. So let's make a table. Let's try to keep that color coding. Okay, so we have take-home pay per month. We have the amount saved, so fraction will be F. The amount saved, so that's going to be the fraction of that. And then the amount spent, or not saved, whatever it is. Tax, or, spent, or paid off bills, or who knows. And then, let's just make a table. There's a table. So the take-home pay last year was the same each month. So let's let that be M, monthly payment. So the pay per month is M. The amount saved is how much in every month. Text box. It's the fraction times that. So it's this fraction of M. And then the amount not saved is just the difference. It's the monthly minus that. Or if you like to think about the fraction instead, you can call it this. It's supposed to be M, not W. So those are the same. You either think of it as everything minus the saved amount, or you think of it as the one minus the fraction that was saved. Those are equivalent. So then these are monthlies. So that means that this is going to be 12 FM saved per year. And this means it's going to be 12 times M minus FM per year, if you need that. So the total amount of money that she had saved at the end of the year, the total saved for the year is 3 times what? Be very, very, very careful. It's 3 times what? Yeah, it's 3 times the amount not saved per month. It's not for the whole year. So it's 3 times the amount not saved in a month, because it's the portion of the monthly. So now that you have your table already made, you can pay more attention to this kind of stuff, because... And I mean, another thing that you'll find this kind of approach does for you is that it prevents silly mistakes from happening. Like, a lot of people would have trouble here because they would mistake monthly for yearly. And so they would, have all kinds of calculations that wouldn't work here. But the way to avoid making oversights like that is to organize like this. Because if you are organized, then you can focus all of your attention on doing this right, and you don't have to waste any of your attention on keeping yourself organized. So it's kind of nice. Total saved for the year is 12 FM. And the amounts not saved in a month is M minus FM. So 3 times that. So then what fraction of this did she save each month? That means we need to solve for F. So we can cancel. We can do 12fm equals 3m minus 3fm. That means that 12f equals 3 minus 3f. So we can add 3f to both sides, and that's 15f equals 3. And so f is 3 over 15, which is 1/5. Any questions about this approach? We're going to talk about another approach in a second. Remember that it's multiple approaches that are the name of the game here. But again, notice that no single step of this process is that hard or that complicated. What makes it hard is that you have to organize it, and if you try to just do this problem as chicken scratch on a piece of paper, then it won't work. So that's the deal here. If you find yourself having lots of trouble with long word problems, what's probably going on there is just that the organizational skills are not up to par. So, and a big part of that is that you're not figuring out what it is that you're doing before you're doing it. So any questions on this approach? I don't see anybody typing anything. So let's look at another approach. What can we do, because we don't know numbers for any of these. So let's take this problem onto the next page. We don't know any numbers here, so what else can we do? Text box. So if we don't figure out algebra, yeah, you want to pick numbers. So a couple of people are saying 100. You really don't want to use 100 here because look at some of these answers, like a third and a sixth. Like, remember, guys, don't just mindlessly memorize stuff. Like, when is 100 a number that's worth picking? Can anybody summarize that? So, like, you know, a couple people are writing 100. You don't want to do this here because, yeah, it's not percentages, right? So the overarching theme here is if someone is spitting out 100, then what that means is that the person is just not thinking about what's happening in the problem and has just mindlessly memorized that you can plug in 100. Not such a great thing here. I mean, the answer is a fifth, so you'll get away with it. But if the answer were a third or a sixth, it would just be the most horrendous thing in the world. So the big thing here is you need a reason to do things. Like if you just memorize the things that you can do, that's useless. Like you can't just memorize things that you can do. Like you have to know when you should use stuff. So like 100, you don't really want to pick 100 unless you're using percentages. So we got our answer choices here, 1/2, 1/3, 1/4, 1/5, 1/6 of the take-home pay. So given these answer choices, you want to pick some take-home pay that is a multiple of all of those numbers, just so that you're covered. So you'd like to have a take-home pay that is a multiple of all of these numbers. So let's pick 60. Monthly take-home is 60. Now, here's my point. My point is, even if you are going to back solve or plug in numbers, you still have to have exactly the same degree of organization. You still have to be just as organized in the same kind of way as if you were going to do algebra. So the back solving and the plugging, those are ways to get around doing the algebra, and they are very, very powerful ways to get around doing the algebra. What they will absolutely not ever get you around is organization. Like if you don't know how to set up the problem, then it's not like you're going to know how to set it up if there are suddenly numbers that you've picked. I mean, the setup is still the same. So let's show this kind of solution, but again, you have to start by organizing in the same sort of way. So all these things that we found out on the last slide, we still need these. So we still need to have the same kind of table here. So even if we're going to pick numbers, we still want that. So here's the problem. Again, just to be redundant for the sake of emphasis, you still need to do that, even if you are picking numbers. Even if you pick numbers. Organize. Read twice. You gotta know what's going on. So the pay per month we decided would be 60. That means that the amount saved would be some fraction of 60. So like one way you can still do this is combined with algebra. So then that's 60 times f. And then that's 1 minus f times 60. If you still want to define that sort of thing. And so then you have the total saved at the end of the year is 3 times monthly not saved. So the saved for the year is 12 times 60 times f, which would be 720f. Equals 3 times monthly not saved. So that's 60 minus 60f. Times 3. So that's 180 minus 180f. So if you solve that, you get 900f is 180. So 1/5. That's an algebra solution, or you can do it with all numbers. You can back solve with the answer choices. And even if you do this again, it doesn't matter. There's still the degree of organization that's necessary. So if you wanted to back solve, we're still going to pick 60 for the pay per month. Let's try answer choice C because it's in the middle. So if you try that, that means it's how much saved per month. If you're trying answer choice C, which is 1/4. So you'd be saving 15 in a month. So that means the amount not saved, that's 15 per month. And so not saved would be 45 per month. So saved for the year versus 3 times monthly not saved. Saved for the year is 15 times 12. That's 180. 3 times monthly not saved is 135. So C is wrong, and then also notice that not enough money has been saved. Or sorry, too much money has been saved. So that means that C is gone, but so are A and B. So too much savings. Those are supposed to be equal. So that means that C is gone, and so are A and B. Because A and B would give you even more money saved and even less money not saved. So you want these to be equal. So then we just try answer choice D. Still 60 per month. That means now 12 per month. It's 1/5. And so then 48 per month. And then you have, let's do the math on that, saved for the year is 144, 12 times 12. And then 3 times monthly not saved equals also 3 times 48 is also 144. So there you go. Choice D works, and you are going to town. But there's 3 solutions to the problem. But the point is that no matter how you solve the problem, you still have to have this organization. Like, the organization is the backbone of all of this. You can't do this work until the problem is organized. And that means figuring out what are the quantities. You don't do any math until you have solid answers to those questions about, like, what's in the problem, what's actually happening, what quantities are there, and how do they work together. So, questions. I see someone typing. Which method out of what? Question that someone is asking is this. I don't really understand the question. Like, which method among what? Oh, you mean, okay, you're talking about, like, algebra versus plugging versus, like, that kind of thing? So, what do you guys think my answer to that's going to be? Text box. See if you guys can, especially any of you old timers. So far what I'm looking for is not up there. Still not really, people are not really feeling it yet. JC is more closer to what I'm getting at here. But, like, let's use common sense and talk about this here. Let's say that you can either let's say that you can make a certain type. I mean, let's say that you are camping and you have a certain type of food. You have some food which you might cook by sunlight or by making a fire. So let's say that someone asks, which method of cooking should you recommend that we learn or master? How would you answer that? Like, if it's a general question, it's not just right now. I mean, in general, if somebody asks, like, which method should we learn, there's a very clear answer here, which people are still not really giving. And it's not whichever cooks the food. Yeah, Kylie, the answer is both. Like, all of the other answers are not the answer. You should not be telling people to learn just one or the other. You should not be telling people to think about what's happening right now. You should be like, dude, there are two methods, and you should learn them both. That's the point. The point is not anything else. Like, you want to be able to do both of these equally well. So then if one of them is not working, you can do the other one. So you say, just learn them both. So same sort of thing. Like, there's no recommendation out of these. And if you think along those lines, then you're going to get killed on this test. Because the whole point of this test, the camping analogy works because, like, if the sun's out, you can use it. If it's not, but you have dry wood, you can make a fire. Sometimes you're going to have the sun and you're going to have dry wood. Then you can just take whatever you're more comfortable with and you can do it. But if you really like making fires, but guess what? The sun's out and the ground is wet, then you're going to starve. If you really like to cook by the sun all the time and you have a cloudy few days, then you're dead. So the same thing will happen on GMAT. Like, there are problems that cannot be done by algebra and can be done very easily by plugging or backsolving. There are also problems that cannot be done by plugging or backsolving that can be done relatively straightforwardly with algebra. The point is you're just going to have to know all of them. That is the point. Like, your only goal is to learn as many ways as you can to solve the problems. You should not worry about which method is best in general, because there's no such thing. For the same reason as there's no such thing as, you know, like cooking by fire is better than cooking by the sun. Well, dude, it depends if the sun is out or if you have sticks. So, right. That's the point. I mean, way too many people are focused on what's the best way to solve the problem. It doesn't matter what the best way to solve the problem is. It really doesn't make any difference. Because the best way to solve a problem will most likely not be the best way to solve the next problem. And, I mean, where this comes from is school. In school, all the problems are the same. You get homework problems that look exactly like each other, and you get test problems that look exactly like homework problems. And so you can memorize that one method is better than all the other methods, and it probably will be. The problem here is it's like weather. You never know what the weather's going to be like. You never know if you'll have sticks on the ground. You never know if you're going to be able to backsolve. You never know if you're going to be able to algebra. You don't know what's going to work and what's not going to work. So one person did ask whether there's a backsolve for this problem. There is a way to do Henry. Where's Henry? There is a way to do Henry by plugging in numbers. Just so we can get to one more problem, I'm not going to do it right now, but if you want to post that on the forum, then feel free to post that on the forum. And we'll show you how to do that there. Let's look at one more problem here. At least one more, depending on how this goes. And then, all right, why don't you try your hand at that? Okay, boys and girls, let's get an answer for this, please. If you could. Okay. Still got a couple of people who don't have answers. I'm looking at you if you are Alda, JJ, Mohit, or that's it. So remember, you got to guess an answer to the problem, even if you don't have one. Okay. Alda, Mohit, you can't not pick an answer, but Just make sure that you know that when you sit for the real test. Okay, here are your results. Again, we are kind of all over the place. So let's take a look. Well, there's a lot of words, so you know the drill for now. Let's forget the math. The math doesn't exist yet. Read through number 1. Math doesn't exist yet, as far as we are concerned. It's just the stuff. So what is the stuff? Well, you have an income tax that you're going to compute. You have 2% of annual income is a quantity. And that's the same quantity. And then you just have this, which is a constant. That's not a variable. That's 100 units. It's like $100. So that's not. We don't need any variables for that, but we at least need to notice it. So and then that's it. Basically, you have tax, and then you have income. So that's all there is. So now let's do the math. Let's go back and read it again. And this time, concentrate on the mathematical relationships. So the tax is computed by, so tax equals 2% of annual income. Let's let the annual income be I, because that's what it tells you to. So you should do that. So the tax is 2% of I. Plus the average of that constant 100 and 1%. So there's your instructions. And you know, if you already know what the quantities are before you do this, it makes it a lot less intimidating to do this. So let's do it. 2% of I is going to be 0.02 I. And then how do we take the average of two quantities? Anybody? Text box. You add them and you divide by 2. So it's the average of 100 plus 0.01 I. So, and we have fractions. So we need to eventually convert to fractions, but let's simplify this first. 0.02 I plus 100 over 2 is 50, plus 0.01 over 2 is 0.005 I. And so that's 0.025 I plus 50. And there's your formula. If you know that 0.025 is 1/40th, then you're done. If you don't, what can you do? Does anybody know? So this is 1/40th. One way to do it is just to go ahead and divide. Yeah, I mean, you can move the decimal over and make it into a fraction. So this is 1/40th. If you don't know that, there's two things you can do. One of them is to do that you guys are talking about in the box. How do you handle this if you don't know? Well, the first thing you can do is you can write it as 25/1000 and then reduce. But there's another thing you can do, which is honestly probably easier, which is to notice that it's got to be A, B, or C because of the 50. And you know that 3/100 is not this. And you know that 1/200 is not this either. So it's got to be C. Like, you don't even have to do that kind of calculation. So you can just notice that it's not A or B. That works too. Any questions about that method? So again, notice the role played by the organization. Notice the role played by the fact that you have exactly these quantities, no more, no less. Does anybody know how else you can do this problem? Let's talk about another way to do it. You can pick a value for I, because it's a formula. So that means that it's going to work for every possible unit of I. So I is still, this is a Vic problem. So you still need to start by doing the same thing. You still need to start with organization. Like, notice that there is only one active quantity, which is income. But you can pick a number for it. So now let's look at what's going on here. Well, we need a number that 200, 100, 40, 50, and 100 all go into. So 200 is nice for that. So let's say that income is 200. So then you want to do the same thing that you did before, which is your tax is 2% of I plus the average of 100 and 1% of I. So let's move that stuff up there a little bit. But now we have a number for I. We have I is $200 or reais or pesos or whatever it's 200 of. So with your number, when you do this VIC, you get the tax is 2% of 200 plus the average of 100 and 1% of 200. So that's 4 plus the average of 102, which is 4 plus 102 over 2 is 51. So that's 55. And then we just see what happens to the answer choices when we input the same value. So if I is 200, that's 50 plus 1. That's not 55. This is 50 plus 600 over 100. That's 50 plus 6. That's too big. This is 50 plus 5. Yay. Happy times. This is over 100, so definitely wrong. This is also over 100, so definitely wrong. So C. The point, though, no matter how you're going to go about doing this, you should know, as we said before with the cooking analogy, you should know how to do both. if you found this problem to be no trouble with algebra, then you should go back and you should figure out how to plug numbers. If you found this problem to be no issue with plugging numbers, then you should go back and figure out how to do algebra. But remember, the name of the game is to A, be organized, and B, to have as many. I think it was JC above that pointed it out, that you got to know them all, and you've got to be able to let go very quickly when you're stuck. That way you can try other ways to solve the problem, if you can let go. So, any questions? I think this is the last problem we're going to do in today's session, because these problems have been taking probably between 20 and 30 minutes to discuss. So that puts us at about an hour and a half. I think we're maybe like 3 minutes short today, but we've had plenty of longer sessions before. So, good stuff. As far as the next one goes, I don't know if we're going to have one on December 15th. If we do have one, it's not going to be with me, because our company actually has our holiday event at exactly that time on that date. So, if there is a Thursday session on December 15th, there'll be a substitute instructor. If not, there are plenty of archives. There's lots and lots and lots of archives. Someone asks, what are the similar problems in the official guide? Well, I mean, I don't have a list right off the top of my head, but for this one, it's really just to go through the OG and find the problems that have lots of words in them. I mean, you know, just walk through the problem-solving section and find the problems with lots of confusing words. That's basically it. I mean, because it's an organization theme, so it really applies to anything where you have a lot of words flying around and trying to confuse you. It's very general. Any other questions? A couple people are typing. No one's typing. Okay, you guys are an awfully quiet group today. All right, so I think we will go ahead and wrap up here. If you have any quick administrative questions, feel free to shoot those over. Otherwise, I will see this group again in the new year of 2012, I guess it's going to be. So happy holiday season to everybody here, and good night and good luck. If you have any quick administrative questions, feel free to shoot them. Otherwise, we will close at this point. All right, I'm going to go ahead and kill the recording. Thank you. Good night and good luck.